All right, another way that we can handle a limiting reagent problem would be if we're just asked to identify the limiting reagent, we can and should compare the quantities provided. So again, we're going to have a look at this balanced equation. If we say that 10 grams of C8H18 octane reacts with 10 grams of O2, and if we ask what is the limiting reagent, we don't need to do all of that two mass problem work. We could just take 10 grams of C8H18 and we could convert this to grams of O2. All right, using that balanced equation and the mole ratio and everything that's there. All right, we're basically going to ask how much O2 is required to consume 10 grams of octane. All right, so we'll set up a mass problem that'll do just that. So 10 grams of C8H18. Right, convert to moles, apply the mole ratio of 25 moles of O2 to 2 moles of C8H18 times the molar mass of O2. All right, this is going to give us the amount of oxygen required, all right, to react completely with 10 grams of octane. All right, so we've got this all set up, and now all we need to do is plug these numbers into a calculator. All right, so times 25 divided by 2 times 32, all right, 17.5 grams of O2. All right, so what this is telling us that in order to completely react with all 10 grams of octane, you need 17.5 grams of oxygen. Now, how does this help us identify the limiting reagent? Well, have a look. There's 17.5 grams of O2 that are required, but only 10 grams of O2 were given to you in the question. So what's preventing this reaction from proceeding? We don't have 17.5 grams of O2. We only have 10 grams of O2. Therefore, that we say that O2 is the limiting reagent and C8H18 octane is the excess reagent. Remember also that we'll often abbreviate limiting reagent, limiting reactant as LR.